Everyone, welcome back to my channel, the new video. In this video, we're going to learn about a new algorithm, very important and nice algorithm for range queries. Because why am I teaching you this algorithm? Because range query questions are very important. And if you don't already know, we're doing a complete data structures algorithms Java interview preparation bootcamp. So check out all the links in the description below. So all the previous lectures, important questions, videos, topics, interviews, links to the code samples, assignments for your practice and everything. Uh, PDF notes can be found in the description below, and highly recommend you to check it out. So let's talk about a range query problem. Let's say you're given an array. Okay, so you're given an array something like this: 13527 13527, again 6, 1, 4 and 8. Indices are 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, the question is find the sum of index numbers between the index 2 and 6, meaning these numbers, index number 2 till 6. What is the sum of this equal to? This is 5 plus 2 plus 7 plus 6 plus 1. So how can we solve this question? How can we solve this question? We can solve this question very simply. Run a for loop from index 2 till 6, time complexity O of n. Okay, in worst case, people will be like, find me the sum of all the, like from the 0th index to the last index. So one by one, you can take the sum of all the indices. Time complexity, worst case O of n. Okay, best case is someone says just one index, find the sum from index number 6 to 6, so constant. But worst case time complexity O of n, this everyone knows is a very simple problem, not a problem. Okay, cool. But now the question is, do better. That's the question. You have to do better, be better in life. You have to do better. You have to do better than O of n. How do we do that? So we're going to learn about a new algorithm. This is known as square root decomposition. Square root decomposition. Now, how does square root decomposition work? So in square root decomposition, here we have it. Just gonna remove my cursor. The cursor is not visible. Okay, now it's good. So square root decomposition, what is it? It's very simple. With square root decomposition, what you do is you divide, it's used to optimize queries, for a particular range, and it reduces the time complexity to square root of n. Reduces time complexity, I will show you how, to big O of square root of n. So rather than n, O of n, it's going to be like, now the complexity is reduced to square root of n. How does that work? So first things first, steps. How can we do this? Step number 1 is divide the array, and this can be any question. It doesn't have to be like, it doesn't have to be like get me the sum between two ranges. No, it can be like the maximum number in two ranges, multiplication in all the numbers in two ranges, minimum, average, whatever you want to take. So square root decomposition, very important, because high chances you will be asked range based query questions. divide the array into blocks of size root n. Okay, then compute answer for every block. I will show you an example, don't worry. If you're not understanding right now, don't worry. Third, given a question or query for left to right, means between two indices, combine the blocks that contain this. I will show you right now. Blocks that contain this. So let's take an example of how this works. Step number 1, divide the array into blocks of size root n. So let's say I have the array. Let's take the previous array only. Okay. So let's say I have this array. Let's say I have this array. This was 1, 3, 5, 2, 7, 6, 1, 4, 8. These are total 9 elements. Now what I have to do is I have to divide this into blocks of root n. So what is root n? Root of 9, 3. So 3 indices I have to combine. This will become 1, 2, 3, 1, 2, 3. So 1, 3 and 5, 2, 7 and 6 are here, and 1, 4, 8. 3 numbers are here. This is index number 0, index number 1, index number 2. These are index number 0, 1, 2, 3, 4, 5, 6, 7, 8. Are you able to understand? Are you able to understand? Let's take another example. Let's say if I say 1, 3, 5, 2, 7, 6. Let's say 3, 1, 4. Okay. 3, 1, 4. And let's say I do one more over here. Let's say 8, because sometimes you'll be like, Kunal, what if there are not even numbers? So here you can see I have to break it down into chunks of 3, because square root of let's say of 10 integer value, it will give me 3. 10 in this case. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'll be like, okay, 3, 3. So 3, 3, 3, then 1, 3, 5, 2, 7, 6, 3, 1, 4, then 8. If there is 8, I will just add 0, 0, because I'm trying to find sum, and anything added to 0 doesn't really change anything. So here I have it. Initially I had 10 indices. Now I only have 4 indices. Every index contains 3 elements. Now I will compute the answer for every block. What is the sum of 1 plus 3 plus 5? 0, 1, 2, 3. Index number 1, index number 0, 1, 2. So 1 plus 3 plus 5. This is 9, this is 15, this is 8, this is 8. This is known as pre-processing. Okay. So what have we done? We have reduced the original array that we had of size n into chunks of root of n. Chunks of root of n. Sounds good? So we have root n elements now, almost root n elements. Okay. Sounds good? So this is known as pre-processing, that I have created my chunks array. That's step number 1. Now this is done. But how do we actually solve questions now? How do I actually solve questions? There can be many cases over here. There can be 3 cases over here. Okay. Case number 1 is, let's say you're trying to say, if I talk about case number 1, let's say you're trying to say that question 1 can be, find the range of index between 3 till 7. So index number 3 till 7 is what? You tell me. Index number 3 till 7. 2, 7, 6. No, 3 till 8. 3 till 8. Not 3 till 7. 3 till 8. What is index number 3 till 8? This one. 276 314. 276 314. Meaning these two. So entire chunks of block will be taken. Nothing is left in middle. Entire block we are taking. That's case number 1. Very simple. Think about what will be case number 2. What will be case number 2? Case number 2 can be something like index number 2 till index number 2 till index number 5. Meaning this one. So meaning 1/3 of this and the whole chunk this. So 1/3 of this and whole of this. Okay, so 15 will be in my answer, and a little bit from the previous index will also be in my answer from the previous chunk. Similarly, the right hand side, step number 3, case number 3 will be what? Case number 3 will be, let's say, index number 6 till index number 9. So in this case, this will be whole and I will take 1/3 of this. 6 till 9. So this will be whole and I'm taking whole and 1/2 of this. Are you able to understand? Okay, so that's what we're going to do. We're going to create the pre-processing table, the array first, and then when we're going to do the query, in the query we're going to be like, solve the left part, solve the middle part, then solve the right part. Okay, for the query. For example, if someone says, I'll take the color blue now. If someone says, give me from the ranges of 2 till 7. So if I talk about 2 till 7, this is the left, this is the middle, this is the right. Okay. Sounds good? All right. One thing I have yet to make you understand is, because we will be querying on this block array. Okay. We will be querying on the block array. Then think about this. The only time we are going to, how do I explain this? This is actually very simple. I'm just trying to understand how to explain this. Hold on, let me think about it. It's very simple. It's common sense actually. Okay, so now I will explain to you what I mean. What I mean is, here you can see that if you're talking about index number, let's say index number, focus on my words, index number 2 till index number, let's say index number 9. So index number 2 till index number 9, you know that this thing is out of the chunk and this thing is out of the chunk. This thing is inside my chunk as it is. Yeah, that is true. Here it is inside my chunk as it is. Are you able to understand? So do you understand that the number of elements on the left hand side and the number of elements on the right hand side will never exceed square root of n? Because that's the number of chunks we have. Number of elements in a chunk, meaning. Okay, I know that if this 2 was a part of a whole chunk, then it would have been in the middle part and not on the left. For example, index from 3 till 9. In that case, index number 3 till 8 is a part of the chunk, so no splitting is required. I can take it as a whole. Index number 1 and index number 2 as a whole, I will take it. And index number 3 in the chunk, I will have to break it down a little bit. So the point I'm trying to make is the breaking down that you're doing, the slicing that you're doing, like 1/3 I will take or whatever, that is never going to exceed square root of n, because the maximum size, the only size of the chunk is square root of n. And if there was a case that's this whole chunk, so for example, you will never do something like for index number 2 till 7, you will never say something like, okay, if it's 2 till 7, then meaning this 5 till index number 7, 1. You will never say something like, okay, I will take 1, 3, 6, and 7 as one chunk and 5 and 2 as other chunk. No, that's not the case. That's not the chunks. In reality, these are the chunks. Square root of 3, square root of 3. Okay, so I hope you're able to understand this. It's very simple. Again, same example, you can take another example. If you are taking from this 5, which is index number 2, till 1, which is index number 7, you will not be like, okay, from index number 2 till index number 5, I will have my left. No, because from index number 2 till index number 5, a chunk already exists. 3, 4, 5. Here, this one. And for that, the answer is already calculated. Already calculated. So the point I'm trying to make, what I'm trying to make you understand is the slice, that the buffer that is in the left hand side and the right hand side that lies outside the whole chunk, that itself will never be equal greater than square root of n, because the maximum size of one chunk is square root of n. Okay, sounds good. So take all the chunks in the middle, then something left in the left, something left in the right. So I will start from the left and I will keep checking till the right. That's it. So I will start from the left till the left chunk is finished. So for index number 2 till 7, I will calculate for index number 2 till 2. This is something I will calculate using for loop, plus middle will be the chunk. So 3 till 5. This will be the whole chunk, plus right hand side 6 till 7. This is how it will work. Left, middle, right. And this left and right, I know that this size will never be greater than root of n. So root n plus root n plus root n, time complexity root n. Simple. Okay. Cool. Now, how are we going to calculate this left part? For any block index I, for any block of index I, so you're saying index 2 till 7, I need to find the answer. So if I talk about the block of, let's say, 4th index, which block does the 4th index lie in? 4th index is 7. Which block does 7 lie in? 7 lies in block 1. How do I know that? How do I know that? It is equal to I divided by root of n, meaning 4 divided by 3, which is 1. Which block does index number 7 lie in? 7 divided by 3, 2. 7 lies, index number 7, which is 1, lies in the block 2. That is correct. That is correct. Simple mathematics. Because you're dividing into 3, root n, root n, root n, every block is root n. That's how you know it. So if you're given an index, so from index left to right, find the answer. You now know how to find which first block to look at. Okay. Sounds good. So if I talk about 2, okay, so I will start checking from the main index. I talk about index number 2. So this will be 2 divided by whatever I'm taking, which is square root of 3. I'll take the what? I'll take the percentage. So the remainder. So for 2 till 7, I'll take 2 modulo 3, which is giving me what? If you want to check, it's giving me 2 only. 2 modulo 3 is index number 2. So start from index number 2. Start from index number 2. My answer will be 5 plus 5 plus what? My low plus plus. So low will now be equal to 3. If I'm starting from left will be equal to, let me start again. Hold on. Let me show you a better example. Hold on. First of all, let me clear my screen and then we will do a dry run. Okay. Let's clear the screen and then do a dry run. Let me just write this down neatly. So, right, I have original array over here. One, 3, 5, 2, 7, 6, 1, 4, 8. This will become 0, 1, 2, 3, 4, 5, 6, 7, 8. This will become sum will become 8. This is 8. This is 15, 9, 0, 1, 2, 3. These are the 3 I'm taking chunks. This was actually 1, 3, 5, 2, 7, 6, 3, 1, 4. Okay, these are the chunks. Now the question is from range 2 till 7. From range 2 till 7. So my leftmost that I'm starting is equal to 2. Rightmost is 7. I will start searching for where is the block of 2. Where is the block of 2? It will be 2 modulo for the left hand side. For the left hand side, I will say left modulo square root of n. This will give me 2 modulo 3, which is equal to 2. So I have to start taking from index number 2. My sum will be equal to 5 for now. Sum. Okay. Sum is equal to 5 right now. Okay. Left plus plus. Left will be now equal to 3. Now I'm over here 3. Now again 3 modulo 3. This gives me 0. When it gives me 0, I know that my block is over. My block is over. So I will come out of the for loop. Now left is done. Now I know that my middle part is left. So I will take this whole chunk as it is. Okay. So I know while left plus, I have to take this whole chunk. In order to take this whole chunk, my right should be ahead of this, because if right was here at 4, then I could not take the whole chunk. Okay, so for middle, I will say if left plus square root of n is less than equal to right, in that case, take that whole block. Sum plus equal to what? Whole block of that index. Which index is this at? Left divided by square root of n. Block. So it's like 3 plus 3 is less than equal to 7. Yes, it is. Take the whole block. Whole block sum is what? Now I don't have to calculate 2 plus 7 plus 6. I don't have to calculate that. I will just take left divide by root of n. 3 divided by 3, 1. Index number 1 I will take 15. Plus 15, I will get 20. and then I will jump my left by square root times. So jump left over here. Left is now equal to 6. Now right part is remaining. For right part, I will check while left is less than equal to right, just keep adding. That's it. So 6, it's in the over here, it's 3. I will add 3, 23. Then it will go ahead 1, it will be 24. And now left is equal to right. So program over, answer is 24. Okay, 5 plus 15, 20 plus 3 plus 1, 24, answer. So this left took square root of n, middle took square root of n, right took square root of n. Even though there's this loop, we know that this left and right maximum that they have will never be greater than root n, because the chunks are of the size root n. Root n plus root n plus root n. Okay. Or root n plus root n minus 2, root n minus 1 or something, whatever. Okay. Sounds good. So one more question is, what if you want to update an element? Same thing you can do. Let's say I want to change index number 4 to something. Let's say I want to change index number 4 to 8. So what will happen is this, you can just say array of 4 is equal to 8. This will change this to 8. But now this is also messed up. I have to change this. It is not 15 now. It should be 16, but it's 15. So I have to change that. So block ID is going to be equal to what? 4 divided by square root of n, which is 1. So I know that this 4 index lies in the block 1. Okay, block 1 I need to change. So I'd say block 1, I'd say I would add the difference in it of the new value minus the current value. So I will say 15 block of 1 is equal to, you can do it in the longer way also, current value plus, or I would just say current value, I just say minus the old value, which was 7 plus the new value 8. So which is equal to 15 plus 8 minus 7, which is equal to what? Block of I plus value that I want to add minus blocks of I. The blocks of the 1 is equal to this old one plus this minus the old one that I had over here. So array of I in the original array. Okay, and then update the array of I. So it will just be like, it's simple. It's like I just rearranged it a little bit. Subtract the old one, add the new one. That's it. Simple. So that was basically about it. Let's try to code this. Simple. Okay, so let's start to code this now. And here I will say that it's very simple. First, I have to make this pre-processing array. I have already shown the dry run, done everything. Notes will be in the description below. This code sample will be also in the description below. And here what I'm going to do is I'm going to close this, make it look more bigger and nice so you can see it clearly. That should be enough. Good enough. Cool. Check out the links in the description below for the code sample and everything. Now let's say int my array is equal to whatever you want to put, 1 3 5 2 7 6 3 1 4 8. This is what we have over here. int n is equal to array dot length. Now build a blocks array. What is square root? Is equal to integer value of math dot square root of n. Okay, blocks array will be of what size? Square root. So square root should be the last index. So square root plus 1. I'd say blocks is equal to new int. This is very simple. We showed the dry run for this. So for example, this was 9. So the last element that I need should be square root of 9. So 3 at least is I need. Okay. That's the number of indices we have. Every index has a size of square root of it. Okay. I will have a blocks ID. Initially, let's say it's -1. I will now try to build my block array. For int I is equal to 0, I is less than n and I plus plus. What I want to do is start from I is equal to 0, then 1, then 2, then I know a block change is required. 3, 4, 5, block change is required. 6, 7, 8, a block change is required. 9. So 0, 1, 2, you can see these are in the remainders of square root of n. Square root of n is, let's say, these are all multiples of square root of n. So 0 is there, 3 is there, 6 is there, 9 is there. If the index I am currently at modulo square root of n becomes 0, I know my new block is starting. New block is starting. I will say block ID plus plus. Okay. Other than that, I will just keep adding in the blocks of ID. Blocks of block ID plus equal to ARR of I. This is how my blocks array will be created. This array over here. I will add 1, then 3, then 5, then it will be like, okay, now you are at index number 3, so you have to change. Come to the next one. So now it will start adding from index to index number 1. So it will add 2, 7, 6, then you will be at index number 6. It will be like, okay, now you're at index number 6, new multiple. So move forward. It will move forward to 2. Okay. Sounds good. Now you can do any query. In this example, let's say we will do the sum query. So query public static int query, you're going to pass the original array as well as blocks. I need an left, right, and I will also pass the square root. Let's say answer is initially 0. In the end, I return the answer. Okay, now what do I need to do? Left part. Again, I've already explained this, so I will just code it. Left part is this. So while my left modulo square root is not equal to 0, I know that I am in the left hand side, and left should also be less than right, and left should not be equal to 0. In that case, keep adding plus equal to ARR of left, left plus plus. Now middle. Middle part. Let's see middle part. If left plus square root of n is less than equal to, so while left plus square root is less than equal to r, I will take that entire chunk plus equal to blocks of that entire chunk, as I've written over here, L divided by square root of n, and my number will be increased by square root of n as well. The left. Right part. if while left is less than right, simple, less than equal to right, just take that is it. That's it. One more function you have to create is update. How are you going to update? Void update. I'm going to update the blocks array. I have to update the original array in index I have to update the new value, and I will pass the square root. What I'm going to do is I'm going to find the block ID first. Which block this index lie in? That is simple, square root of I divided by square root of n. After that, blocks is equal to blocks plus, so blocks of block ID plus equal to new value minus old value. New value minus old value is ARR of I. And then after this I will change ARR of I also equal to the new value. That's it. Okay, sounds good. Can also print system dot out dot println. I shared with you where you might find that doubt in the left and right, but please remember the maximum loop that will run, it will not be greater than root n. That is why complexity is root n. Let's do blocks. Let me run this. Okay, so I run this, I should get 9 15 8 8. 9 15 8 8. Simple. Try to get sum between 2 to 7 should give 24. Query blocks ARR 2 7. What is square root 3? $24. Easy. So please remember, it's not just for sum. This program algorithm now you can use for anything. Sum between two indices, greatest between two indices, like maximum between two indices, average between two indices, some other rule between two indices, anything it can be that you can solve now in square root of n. So I shared with you where you might find doubt. I shared with you like the dedicated example and the working and the steps and all these other things, why we're using it. Check out the links in the description below. This code you can run directly on your browser as well. My same code, I will leave the link in the description below. Code and assignments and all the links and everything can be found in the description below. Make sure you like, share and subscribe, and I'll post more videos. If you have any questions, leave them in the comment section below. If you have any requests for any other video, please leave this in the comment section of this video, and you can share with using hashtag DSA with Kunal on social medias like Twitter and LinkedIn, and join the Learning Public Initiative. See what other people are working on, ask your questions over there, join our Discord, all the usual stuff. Thanks a lot for watching. See you in the next one. Have a great day. Bye.